All right, with final exams just around the corner, we are going to crack one of the trickiest topics in engineering economics. Welcome to your ultimate exam review on how to solve shifted uniform series problems. Okay, let's just dive right in.
You ever look at a cash flow diagram where the payments don't start neatly at year one, and you just feel your brain start to spin a little? Yeah, you are definitely not alone. These are called shifted series, and they are a classic stumbling block. But I promise, by the end of this, you are going to be solving them like a pro.
So what are we really up against here?
Well, a shifted uniform series is pretty much what it sounds like. It's a standard repeating payment, an annuity. But the whole thing's been pushed forward in time. It doesn't start at the end of period one. And that little shift changes everything about how we find its value today.
So here's our game plan. We're going to start with 2 golden rules that are the key to, well, everything. Then we'll walk through a 5-step method for doing it by hand, power things up with some spreadsheet skills, run through a final exam-style drill, and then wrap it all up with the key takeaways. Sound good? Let's go.
First up, the absolute foundation. I'm not kidding. Almost every single mistake on these problems comes from not knowing these 2 simple rules. If you can master where to place your P and your F, you've already won half the battle.
Here they are, the 2 rules you have to burn into your memory. Rule number 1, when you use the P/A factor to find the present worth of a series, the answer, we'll call it P prime, is always located 1 period before the first payment. And rule 2, for the future worth using the F/A factor, the answer F lands in the exact same period as the very last payment. Get these 2 right and you'll sidestep the most common traps.
Let's just visualize that first rule because it's the tricky one. So if your first payment, your first A, happens at year 4, then the present worth of that series, or P prime, is actually sitting back at year 3. It's always 1 step back. That's just how the math in the original formula was built.
And here's the second rule, which is way more intuitive. If your last payment A is at year 13, guess what? The future worth F of that whole series is also at year 13. It lands right on the same spot. Easy enough, right? Okay, now let's see how these rules fit into a full-blown method.
All right, now that we have the rules down, let's build a foolproof, step-by-step process so you can solve these problems by hand every single time. Think of this as your checklist for success.
We're going to follow these 5 simple steps. First, draw the thing. Second, use our golden rule to locate your P prime. Third, and this is super important, figure out the right N value. Fourth, know what the question is actually asking for. And finally, step 5, set up the math and solve.
Okay, time to put this into action. Here's a classic exam-style problem. We've got an upfront cost of $5,000 and then a series of 6 annual upgrade payments of $500. But here's the catch. That series doesn't start until year 3. So the question is, what's the total present worth of everything right now at time 0?
Okay, this right here. This is the step where most people go wrong. They use the wrong N. Let's look closely. The payments are in years 3, 4, 5, 6, 7, and 8. If you just count them on your fingers, that's 6 payments, so we know N equals 6. The best way to see this clearly is to just renumber the timeline for the series itself. So year 3 becomes our new year 1, year 4 becomes our new year 2, all the way up to year 6. Now, applying our golden rule, where does P prime land? 1 period before our new first payment, which is at actual year 2. See that?
So how do we write the equation? Well, first we have that initial $5,000 payment. That's easy. It's already sitting at time 0. Done. Next, we find the present worth of that $500 series. That's the P/A factor with our N of 6. That calculation gives us the value of the series at year 2, our P prime. But we need the value at year 0, right? So we have to treat that P prime like it's a single chunk of future money and discount it back 2 years using the P/F factor.
We just plug in the numbers from the factor tables, run the calculation, add it to our initial $5,000, and there it is. The total present worth of this whole software deal is $6,981.60. See? The method works perfectly. Now, while doing it by hand is absolutely crucial for understanding the concept, let's be real. In the real world, and probably on your exam, we use spreadsheets. So let's look at how to use the NPV and PMT functions to solve these things way faster. Okay, there's one really important quirk you have to know about the net present value, or NPV function. It's kind of weird. It assumes the first cash flow in the range you give it is at the end of period 1, so it can't handle a time 0 cash flow. You have to handle that one separately.
The correct formula is always NPV of the range starting from year 1, and then you just add the year 0 cash flow cell outside the function.
So what if the question asks you to find an equivalent annual series, the A value, for the whole project? Well, you've got two options. The simple two-step way is to first find the total present worth using NPV in one cell. Then, in a second cell, use the PMT function to spread that p-value out. Or, if you want to get fancy, the pro move is to embed the entire NPV calculation right inside the PMT function. It's all one formula. Super clean, super efficient.
All right, let's put it all together. This next problem is kind of like the final boss. It combines a uniform series with a couple of random single payments thrown in. This is exactly the kind of messy, multi-step problem you should expect to see on your exam.
Here's the deal. A 20-year lease payment of $20,000 a year. And notice, this one is a standard series. It starts in year 1. But on top of that, there are 2 bonus payments, $10,000 in year 6 and $15,000 in year 16. The question is, what's all that worth as a single lump sum today? Now, I want you to actually pause this explainer. Go on, hit pause. Try to set up the solution yourself.
Okay, you back? How'd it go? The secret to a problem that looks complicated like this is just to break it down into simple pieces. We really have 3 different things going on. We have the 20-year annual series, we have a single payment in year 6, and we have another single payment in year 16. The game plan is simple. Find the present worth of each of those 3 things on their own, and then just add them all up.
And this is what that setup should look like. The total present worth, PT, is the sum of 3 parts. First, the present worth of the annual series. That's a straightforward P/A calculation since it starts at year 1. Second, the present worth of the $10,000, which we just pull back from year 6 with a P/F factor. And third, the present worth of the $15,000, which we pull all the way back from year 16 with another P/F factor. See? When you break it down, it's not so bad. Whew, okay, we have covered a ton of ground. So let's boil all of this down into a quick cheat sheet. The absolute most important things you need to remember for your exam.
Here it is, short and sweet. First, know those golden rules for P and F placement. P is 1 before, F is at the end. Second, always renumber your timeline to find the correct end for a shifted series. That is the #1 trick. Third, master the weird NPV syntax. You have to add that year 0 cash flow separately. And finally, if a problem ever looks overwhelming, just break it down. Solve the simple pieces first and then add them up. So, at the end of the day, what's the big secret here? It all comes down to one thing: drawing that cash flow diagram. It isn't just a suggestion. It is the most powerful tool you have. If you can accurately map out where the money is on the timeline, you can solve anything they throw at you. Master the timeline, and you will master the problem. You got this. Good luck on your exams.